Okay, so today we're going to talk about the concept of stoichiometry. Now, the concept of stoichiometry might sound a bit hard, but we're going to start with something really simple. We want to convert 1 mole of any material to grams. Okay, in order to convert them, we have to have something here in the middle. So what we are talking about is found in the periodic table. Something here in the periodic table is going to help us convert the moles to grams, okay? So what is that thing? Well, if we look really close to the periodic table, okay, that's a nifty little trick. Now, how do I do that again? Okay, so if we really look close, we have two things. We have one atomic number, and we have our atomic weight here. Okay, and this is the number of atomic weight. So for beryllium, it would be almost 10, okay? And for any element, we could find the atomic weight. It's for most intents and purposes, should be bigger than your regular number. So in the case of hydrogen, for example, we have 1 as atomic number, but we have 1.08 as a molecular, as an atomic mass, or the molecular mass. Okay, so right now we have something called the AR. And what we do is basically think like this. 1 mole of a given anything would have AR that we can find from the atomic table, and this would give this particular mass in grams, okay? So we could also go the other way around, but you might be thinking, but this is not the stoichiometry that we used in a lot of the reactions that we saw. That stoichiometry should be a little bit harder than what you are right now explaining. Well, it's not hard. It's based on the reactions themselves, okay? So when we say a balanced equation or a balanced reaction, what we mean is that in both sides of any equation, everything should be equal. So if you have 2 hydrogen atoms here, you should have 2 hydrogen atoms here. And if you have 4 carbons here, you should also have 4 carbons here. And if for any reason these are contained in different containers, for example, and they are producing different things, and we have oxygen, let's say that we have 2 oxygens here, then we should have 2 oxygens here. So this is it. For any reaction that is occurring across the tables and across everything, we have to have a balanced relationship to describe them. And the problem was that we couldn't describe them with grams, because then you would have a lot of conversion to do. But we could describe them with the idea of a mole. And the idea of a mole comes from the fact that each mole of any material, any element, would have the same exact number of molecules or atoms. And that number would be 6.02 to the 10 to the power 23. Okay? So that's why we always do it using the mole. It's like saying that you have a couple of atoms and another couple of atoms and another couple of atoms, and it would always have 2 in them. That's what I'm trying to tell you. So the reason why we use moles again is because despite the number of grams or milligrams or tons that we are using, it's so much easier to actually look at reactions when we are looking at the number of molecules or atoms reacting, okay? And that's exactly what stoichiometry is about. Stoichiometry is just counting how many molecules or atoms we have. And because we can't keep writing 6.02 to the 10 to the power of 23, we came up with a term that is called the mole. So, you never see something like this. 6.02 to the 10 to the power 23 hydrogen plus 6.02 to the 10 to the power 23 oxygen. Instead, you would see hydrogen as 1 mole plus oxygen as 1 mole. And they are giving us H2O. This is a not balanced equation. But it's so much easier to balance this compared to this. Okay? So, how do we balance our equations, or why do we balance our equations? Because in the known universe, we have no new materials popping up. There are millions and billions and hundreds of billions of atoms out there. Countless really. But nothing is new to Earth. Everything was in it, everything is going to go back in it. So every hydrogen atom ever encountered in your life was there since the start of creation. So the idea is that there is no material that is being created and there is no material that is being destroyed. Everything is being converted from one form to the other, but nothing is really destroyed or lost. For example, in our breathing, we really burn a lot of carbon. So we use a lot of carbon and oxygen and we produce CO2. Okay? This is regular reaction where we burn coal, for example, or we are breathing. And I'm just too lazy to write C6H6O12. But basically, this reaction, we don't lose the carbons, we only have them in a new form. And we don't lose the oxygens, we only have them connected to the carbon. But nothing is lost, everything is accounted for. Okay, so how does that help me determine how much something is in something else? And this is what we need to get to, especially in a lot of reactions where we are asking you about certain grams or certain things. So if you have a new balanced equation, okay, for example, we have this following equation: H2SO4 plus 2NaOH, which is a typical acid-base reaction. And that would give us 2H2O plus Na2SO4. Okay. So we might give you something like this. We gave you the grams of this. Calculate the grams produced of this. So if I give you, for example, 1 gram of H2SO4 and ask you to calculate how many grams of Na2SO4 you have, it might sound a little bit magical. But again, remember that we had our periodic tables. And our periodic tables were so beautiful because they gave us a connection between our grams and our moles, right? Okay, so in this case, first of all, let's check out if our equation is balanced. If this was a balanced equation. So we have 2 hydrogens here. We have 1 hydrogen here, but it's multiplied by 2. So we have 2 hydrogens here, 2 hydrogens here, okay? And we have 2 hydrogens here, but they are multiplied by this 2, so there are 4 hydrogens. So 2 and 2 and 2 and 2 is going to be 4. So for hydrogen, this is balanced. Let's look at oxygen. We have 2 oxygens here. We have 4 oxygens here. And in this case, we have 1 oxygen here, but it's multiplied by 2. So we have the 2. And so we have 2 oxygens here. And we also have 1, 2, 3, 4 in the Na2SO4. So in this case, we have 6 oxygens being reacting and 6 oxygens being produced. Okay, good. What about sulfur? We have one sulfur here and one sulfur here. What about Na? Two NAs here and two NAs here. So it's a very balanced equation. Okay. Now, so we want to go from 1 gram to grams of Na2SO4, which is our question. What do we do? Well, first of all, let's do this. Let's write what we have here based on our equation. Whatever you start with would be okay. If you start with calculations, it would be okay. If you start with stoichiometry, it would be okay. So what stoichiometry means is how much is going to go inside the reaction and how much is going to go outside. Or how much ratio do you have of something against something else. Okay? So for example, if I'm telling you that for each real I have, you would have 3. And that this ratio would always hold. And if I have 3 reals, you should have 9. And if I have 10 reals, you should have 30. So the same thing goes with atoms and things like that. So, now, enough about money, let's talk about moles. So in this case, we have 1 mole, H2SO4. And this is giving us 1 mole Na2SO4. How did I get this? I got this from our lovely balanced equation. In order to get a correct stoichiometry, you have to have a balanced equation. Everything must be accounted for. Okay, so now I got this. I got the stoichiometry. How am I going to go from grams to grams? Okay, remember our periodic table and remember that everything has a beautiful function in it, which is the atomic relative mass. So we can calculate the molecular weight of H2SO4, which would be, okay, let me just get this. The molecular weight of H2SO4 would be something around 98, because we have 2 hydrogens and that's 2. We have 4 by 16 and we have 32. Okay, so the 98 is given a really nifty, so I'm going to just wipe this down, is given a really nifty unit, which is grams per mole. You can see what we're heading to right now. We also have the Na2SO4, so let's calculate for that. Mr for Na2SO4, and I prefer you write this in the exam and anything. I prefer when you write something, write down what you mean by it. So Mr Na2SO4 is equal to 2 NAs plus 32 plus 16 by 4. I forgot how much Na weighs, so I am going to have to go back to the periodic table. So that's almost 23. Okay, so I'm just going to wipe this down to write the final answer, which we've got here, which would be 142 grams per mole. Now, why is writing units really important? Writing units keeps you from making mistakes. So at least you know that when something is grams per mole, you should multiply by moles to get grams, or you should multiply by grams to get moles. Okay, so in this case you have the MR for everything. You have 1-to-1 ratio. So the question becomes, how many moles are found in 1 gram of H2SO4? So that's what we are asking right now. How many moles of H2SO4 are found in 1 gram? Okay, because we have the molecular formula, we have the grams, we have the stoichiometric ratio. We don't have any idea how many moles are there to compare them to the stoichiometric ratio. So it's like going in a road like this. So, yeah. So, how many moles of H2SO4? Moles are always presented by N. N of H2SO4 is 1 gram per mole. Is that correct? That's not correct. We have 1 gram, sorry, not 1 gram per mole. 1 gram over 98 grams per mole. Right? Because this is the molecular formula. And that's why you should write these symbols. Okay, so it's 1 over 98. And that would almost be 0.01 moles. But let me check my answer. Right. Okay, so we have the number of moles of H2SO4. What are we going to do now? Well, let's go to a new table. So now we have 0.01 mole H2SO4. This is something that we know. In 1 gram H2SO4, and this was based on our lovely MR. So you just need to convert this to Na2SO4. So remember this that we got from the 1 mole H2SO4 gave us 1 mole Na2SO4, and so 0.01 H2SO4 is 0.01 Na2SO4. Okay, but our work is not finished. We need to get the grams for this. So the final answer that you should have is this. The mass of Na2SO4 should be 1.42 grams. You can check your answer and actually talk to me later. So thank you so much for listening. Hope you had a nice time.